And then on the next page, our last topic is variation. So topic 7, we've got direct, joint, and inverse variation. So let's get these formulas on here so we can use them. So our direct variation, we have y equals k times x. Joint variation, we have y equals k times x times z. And then our inverse variation, we have y equals k over x. All right, so first you guys are just practicing setting up what an equation would look like before you sub things in. So 34, s varies jointly with. So normally when you see this one first, that's the one that's by itself. And then jointly means the k gets multiplied jointly with t cubed and v. So you'd set it up like that. Number 35, we have m varies, so that's the one that's by itself, just like the y is up here. Inversely, so you've got the k is always in the numerator. N squared is the inverse one, so that one gets divided, and then directly with p, so that means the p gets multiplied by the k. So sorry, that's a second power right there that kind of got blended in with the p. All right, it's 36, 37, 38. We are determining just what type of variation it is and identifying what k is there. So number 36, this one's a little sneaky because the 3 is on the wrong side of the equation, so we would divide it over to the right to get the y by itself. So it'd be a 1/3 on the right once it gets divided over. So with the y by itself, we have 2 variables that are multiplied, so that would be a joint variation, and in that variation, the constant is 1/3. Make sure you simplify that first. This one, we could really go either way. It kind of depends on which one we want to be the variable by itself. Let's say just since the d is on the left side of the equation, that we want the d to be by itself. So if we multiply both sides by 2, we get 2r. Since the variable is multiplied and there's only one variable that is direct, and the constant there is a 2. That's what's multiplied by the r. This one is a little bit tricky too. We want to get the y by itself, I would say. So a couple different ways to do this. You could cross multiply, do a little proportion. So let's say we cross multiply here, we get x times y. Cross multiply 8 times 6, we get 48. So to get the y by itself like we're used to, we would have to divide both sides by x. So the 48 would get divided by x. So you can see once that's simplified a little bit, it is now set up like inverse variation. And once that's set up, the constant is in the numerator, so that would be 48. All right, so none of these were just handed directly to you. You had to do a little bit of work to figure out what type of variation it was. All right, so 4 of these examples, and then we are done. So these ones are a little bit more direct. These ones are your story problems. So number 39, we start with w varies directly as r cubed and inversely as s. So that's your setup. Just kind of reading that first sentence and doing a little bit of practice here allows you to set up your equation, sub in the first set of values so you can figure out what k is. So we have w is 24 when r is 4 and s is 8. Okay, so we use that to solve for k, and then once we find k, we can actually answer the question. So this 4 cubed is 64, and 64 divided by 8 is 8. So we have 8k. So this 24 equals 8k. If I divide both sides of the equation by 8, 24 divided by 8 is 3. So that gives me the value of k. Then I can sub that into this equation along with the value of w and the value of s. So I have w equals k times r cubed, so that's what I'm solving for, and s is 27. Okay, so let's reduce the 3 over 27. 3 over 27 reduces to 1 over 9. And then I am going to multiply the 9 to the other side of the equation. So 81 times 9 ends up being 729 equals r cubed. And then to solve for r, we would take the cube root. So this is one of the values that you guys had way back in your list of perfect squares and cubes and fourths. So the cubed roots of 729 ends up being 9. So I get r equals 9 for this one. Okay, let's do something very similar for number 40. So B varies jointly with A and C. So we have that set up. They give us the first set of information, so we can use that to solve K. So B equals 112, and A is 12, and C is 7. Okay, so we can use that, solve for K. So 12 times 7 is 84. So we divide both sides by 84 to get a value of K. Okay, so I think we're just going to go with a decimal here. So just to show you my screen, 112 divided by 84, we get 1.3 repeating. So 1.3 repeating we know is 4/3. That actually might be a better way, just to stick with the fraction, make sure our next answer turns out exact. So now we know K, we want to solve for A, we know B, we know C. So back into this same equation, B is 72, K is 4/3, we don't know A, we know that C is 2. All right, so 4/3 times 2 is 8/3, and we're solving for A. So to get A by itself, we want to multiply by the reciprocal, both sides, which would be 3/8. Okay, so here we get A by itself. So let's see what A is. So 72 divided by 8 is 9. 9 times 3 is 27. Okay, so just two more here. These are your story problem types. We have the wind force F varies jointly as the area and the square of wind speed. So let's see. Wind force varies jointly as the area of the sail and the square of the wind speed. So like that. So that's your setup. So basically you're doing just what you did with problems like up above, except it's got a little context behind it. So the force with an area of 500 feet is 64.8 pounds when the wind speed is 18. So we use all that information to solve for K first. So the force is 64.8 pounds when the area is 500 feet squared and the wind speed is 18 miles per hour. So we sub that all in. So let's get a nice little decimal here. So to get K by itself, we're going to be taking 64.8 and we're going to be dividing it by 500 times 18 squared. So we get 0.0004. So all those decimals are very important. So K is 0.0004. That's going to help us get a nice accurate answer for the rest of this. So this is what would be the force. So we're solving for F. For a sail with an area of 250 feet. So we now know that K is 0.0004. The area is 250 feet and the wind speed is 35. And remember in the formula that gets squared. So we can just sub this in. So 0.0004 times 250 for A times 35 squared. So we get 122.5, and then make sure you include units because this is something that has a context behind it, and the force is given in pounds. So this would be 122.5 pounds. All right, last one. So you've got volume of a gas varies directly as the temperature and inversely, so a combination here. So volume varies directly as the temperature and inversely as the pressure P. So that's your setup. We have an initial set of information that we can use to solve for K. So at a temperature of 200, so that's T, pressure of 500, that's P, the volume is 240. So let's solve all that in. So 240 is V. We do not know K. The temperature is 200, and then the pressure is 500. So we sub all that in. We're solving for K. So we're going to multiply by the reciprocal here. So we have 240. We're going to multiply by the reciprocal of this fraction right here. So 500 over 200. And so this ends up being 600. So that's your value of K, is 600. And we can use that in the next equation to solve. So we are going to set up, it says find the volume of the gas. So V equals, we now know that K is 600 times T. So this is a temperature of 275. And pressure is the inverse variation. We're subbing that in as 400. So just take that numerical expression, sub it in, and we'll get volume. So we have 600 times 275 divided by a pressure of 400. And that reduces down to 412.5. So that's your volume. And our volume here, it gave us centimeters cubed, so you would use the exact same units